Hello, my name is Michael Pentecost. I'm the Street Superintendent for the City of North Liberty, and I'm here today to talk a little bit about traffic-controlled intersections with signalization and how they work. 20 years ago, North Liberty didn't have any signalizations. Now we have 16 different intersections that are controlled through signals, our latest being the Forever Green I-380 on and off ramp. The four different types of detections are the puck system, which you'll see a little round black puck, one of these guys, and they're in the concrete, but you'll see it's kind of rubber coated, and those detect your car driving over that, noting to the cabinet to change during the next cycle. Another system that you'll see is lines cut in the concrete, and that's a loop system. That's a hardwired system back to the cabinet. The puck systems use a radio frequency to send their information back to the cabinet. Third, at the intersection on the poles, you'll see cameras. Cameras will visually detect the image of the vehicle. And the fourth is a radar frequency, similar to a radar frequency detecting speed. All of these systems have pros and all of them have drawbacks. So it's not necessarily a one system fits every situation, but our systems are primarily on the pod system. We've had the ability to have backup to these detection systems so that if a primary, say a pod system goes down, we can use a camera system that's already set up and ready to go to detect those intersections. All of our traffic signal intersections are either set up with generator backup or battery backup or both. And that helps in the event of power loss that those intersections still can be controlled as normal. That is a feature that has been beneficial in the past for power losses and storms like derecho or other issues. So our systems are set up to move the largest volume of traffic, and those roads would mainly consist of our Rancho Way, Penn Street, and Forever Green. All your side streets, say a 240th or a Cherry Street intersection, it's going to give priority to those main routes. So if you're setting at an intersection longer on those side streets, that's the reason. And those timings, they adjust depending on the flow of traffic. So if there's a lot of volume on those primary routes, you're going to see that length of time of that signal change is going to spread out longer to move those queues of traffic more efficiently through the town. You'll see that at times when you have maybe an accident on 380 or an Iowa game going on. Those signals do communicate with each other and adjust accordingly for those timings. One thing you'll notice if you're a resident in town is those side streets will change over faster in the evenings because that traffic volume isn't as high on those primary routes.
My name is Lange, the Assistant Streets Superintendent here in North Liberty. We're standing in front of one of our standard traffic signal cabinets. This is the main controller here. Takes all the signals from the detection into that and operates the system. This is the conflict monitor to make sure that no red or greens come on at the same time. This is the battery backup system here in case we lose power. Right now we could probably run about 4 to 6 hours on just batteries. We also have generator hookups that we can hook on to charge the batteries, so we can pretty much run a system as long as we have a generator available to us out in the field here. Every cabinet throughout the entire town is hooked up through fiber that relays back to our street department shop, to our servers that take all this information and then make sure that they're all coordinated between each other. We have a couple pieces of equipment at the top here. This is usually the detector part of it. We have video from our video cameras out in the field that come into these cards here. We have loops at this intersection, which we don't have at all the other intersections. These are those cards that take that information. And then our pod system, our primary system that's out in the field, is this last card over here. That's 3 different detection systems working, and they all get fed into that controller. At this intersection, 240th and Rancho Way, we currently have 3 different types of detections. Primary system is the pod system. That's the in-pavement system that detects your car, but the stop bar is very important to that system because it's stationary in the pavement. If you pull beyond that white stop bar line, it won't detect you. The video system works in the same manner, but there's just a video that detects you, and we can kind of set those wherever we want from that stop bar back. Then the loop system is the oldest system that we've been replacing with the newer technology as we go. Traffic signals, when it comes to new subdivisions, every intersection had some sort of warrant done by an engineering company. They come out and take vehicle counts, and then they have charts that they use to show your level of service for an intersection. Everything's based off of those numbers and studies to determine whether or not a traffic signal gets installed. So any new developments that come in on all of our main roads are always studied and have some sort of warrant applied to that intersection. So this is some of the traffic signal data that we can see what's happening out in the field from the pod system on this screen here. On this screen is our central software. We get all of our alarms from that system. Just a quick overview of what's happening. All green is good. The adaptive system is set up in kind of 3 corridors. We have a 965 corridor, West Penn Street corridor, and then we have a West Forever Green corridor out here with the newest ones on 380 and 80. They're kind of out there by themselves. This is where it's taking all of the detector information and then calculating out all the active targets and stuff throughout the city and then changing the cycle length to adapt to the traffic that's out there.